Melanin is an ubiquitous pigment. You're going to hear a lot about melanin in today's session and perhaps a little bit later in the afternoon with Matt Shockey talking a little bit about how it plays a role in color. So let's start with Andrew and we'll take it from there.
It's so great to be in a room with some like-minded people who are sharing similar types of visions. And, we have this whole thing called Biocene and Biomimicry. And we think of this as some sort of a new term. Biomimicry has been around for as long as people have been around. We've always been taking inspiration from nature and how to do things. And, this is Ohio. It's the birthplace of aviation. And if we had the Wright brothers here, and if you look at their early versions of, how they were trying to make a heavier than air flying object, they took inspiration from birds. Most of their early designs, and along with other inventors, all had flapping wings or movable parts. They were trying to imitate birds. And so that's a little bit of just a diversion, but I'm Andrew Trunek. I'm at NASA Glenn Research Center, and I have to blame Dr. Ali Dinajwala for my interest in melanin. About a decade ago, I attended a presentation by him where he was talking about the colors of feathers in birds, and I thought, this is pretty interesting stuff. And that kind of started me on a path of looking at melanin as a very interesting material. So if we can, do I use this clicker? All right. Oh, terrific. Okay. Very good. So, as Ali said, I'm sorry. Melanin is a very ubiquitous material, and it's literally throughout the biosphere, and is present in everything from bacteria to humans. And even though as common as it is, all you have to do is just look at your hands and you are seeing melanin. But as much and as common as it is, we really don't truly understand it as well as we would hope to. It's a very unique material. It's interesting, but it's perplexing. It literally is present in organisms that are deep in the ocean. Clearly, there's no sunlight or UV exposure. So why is melanin present in the depths of the oceans, and including, to the tops of mountains? One of the things that is really interesting is melanin is present in lichen that live in the McMurdo Dry Valleys, which is about, it's in towards the South Pole, and it's about as Mars-like as we can get. It's estimated that it hasn't physically rained in the McMurdo Dry Valleys in about 1 million years. So, and it has a much higher radiation level than we do here in the Earth area. So let me go to the next slide. I like to look at this screen versus the small one, but that's okay. So what is melanin? Melanin is it's a general term, and I like to use analogies. So, when we talk about melanin, there's very different types of melanins out there, but it's a biopolymer. And you say, well, what is a biopolymer? It's basically just things that are, fingernails, hair, the shells of crabs, chitin, all of those sort of things are just basically structural materials that are produced by living organisms, and including melanin. So it really isn't that phenomenal, but that kind of gives you an idea of what a biopolymer is. And we see it in things like cellulose, lignin that is in wood pulp, collagen, alginate, which is in brown seaweed, and gelatin. And there's, like I said, melanin is a general term. There are very separate kinds of melanins. eumelanin is from light brown to dark brown. Pheomelanin, because of a certain amount of sulfur content, tends to be more towards the yellow and orange. Then we have allomelanin, sorry about that, and biomelanin and neuromelanin. And I'm going to go into each of these in just a little bit more detail. So it's a general term, and like I said, I like to use analogies. We typically just lump all these things together and just call them melanin. And a good analogy is milk. If you go to your refrigerator and you look and say, oh, I'm out of milk. But then you go to the grocery, so you put down on your grocery list that you need to go buy some milk next time you're in the store. But yet you go to the store and, there's whole milk, 2% milk, 1% milk, skim milk, almond milk, lactose-free milk, goat milk, but you don't put the individual types of milk that you want from the grocery store. You just call it milk. And we do the same thing as researchers. We just lump all these things together and call them melanins. And we really only get into the specifics of what type of melanin when it makes a true difference. So that's one of the things that, it is a general term, but there are not only, these are broad classifications, and then within each one of these, there's variations that are influenced, if we talk about, eumelanin, genetics, DNA, or in a plant, its local environment, what is available as far as nutrients, all affect how that melanin develops. So we can kind of thank this whole process on very poor reactor design and some mistakes by some individuals. In 1986, reactor number 4 at Chernobyl, due to some mistakes, it blew up and created a biological disaster, a natural disaster. And it was such of a hazardous event that, they basically covered it over in concrete, and, in a couple of thousand years, everything will be okay. So about a decade later, they went in and they kind of wanted to go into this reactor and find out what the heck was going on in there, but it was so dangerous that they used robotic exploration to kind of go in there and take a look around. And what they found was completely surprising is there was a pretty high level of black mold growing in the reactor area. And not only was this mold surviving and growing, it was actually growing in the direction of radiation. And there was a very early paper written and it was published only in Cyrillic, and then unless you're schooled and learning how to or know how to read Cyrillic, good luck on that. So there's 2 people that ended up, basically, I have a feeling that they must have read that paper and wrote another paper. This was a guy named Arturo Casadevall and a lady named Ekaterina Kate Datakova. I think Rada knows Arturo fairly well because he works at Johns Hopkins University, and he's Rada's business partner. Anyhow, that paper basically opened up the eyes to the world that there is some pretty crazy stuff going on in this reactor. And it's like, these mushrooms, this is almost immediately deadly to humans. And these mushrooms are not only just growing in there and surviving, they're actually growing towards the source of radiation. And so what we have here is melanin is very important to the human being. And papers and all the publications and research that was done about melanin was basically focused on, what's its effect on humans, and they were basically in medical journals, medical publications, medical research, because of its importance to humans. And what we see is that publications that were based in the non-medical field were down in the dirt, almost nothing. And then you see the paper that was published by Arturo and Dodakova, and then from that point on, non-medical melanin publications have just skyrocketed and increased with the discovery that you have these highly melanized fungi living in a high radiation environment. So I'm going to go just a little bit about the properties of melanin in general, and then from this point on, I'm not going to go into specifics about different types of melanins, but it is basically a broadband absorber of, so it gives us good photo protection. We just talked about the fact that it seems to be extremely radiation tolerant. It has high thermal regulation, basically can be used to moderate temperatures. It is extremely chemical tolerant, and I don't want to steal Rada's thunder, but you can basically dissolve organic material in acid, and it will be just fine. And in fact, that's one of the ways that you get rid of all the other organic material is put it in acid, dissolve everything else away, and what you're left with is melanin. It's hygroscopic, which I talked about, these lichen that live in the McMurdo Dry valleys. It helps these lichens survive and absorb what very little moisture is there. And it has an affinity for free radicals. Free radicals, these are things that are looking to be something else. They're in a high energy state. They don't want to be there. Again, another analogy is if you've ever washed a cast iron pan, by the time you dry it, there's a surface layer of rust on it. That's Fe2. It doesn't want to be Fe2. It immediately reacts with oxygen and becomes rust. So melanin is very good at absorbing some of those, reacting with those materials. It is mechanically tough. We've heard John Sankovic talk about, the evolution and the fossil of Ohio. And the fact is, melanin survives fossilization. When we see the imprints of different fossils in rocks, all the organic material has long disappeared. But what survives? Melanin. And that's what produces the shadow and the imprint in the rock or the fossil that allows us to see what this animal or fish or whatever it might have been was in some previous form. It has semiconductor-like properties. You can literally turn it off and on like a transistor. And it participates not both in ionic conduction, but electron hole conduction. Now, our bodies are electrical systems. Our nerves, our heart, everything that we do, how we basically survive is through ionic conduction through our nervous system. And that is assisted by melanin. But at the same time, if we want to make electronics out of this or sensors, we kind of need electron hole conduction. And it's been demonstrated that you can literally turn this thing off and on like a light switch. So what are some of the things that we could use this for in non-medical applications? Energy harvesting. If this thing is absorbing radiation, we know that energy can neither be created nor destroyed, but we can change it from one form to another. And so if these fungi are absorbing radiation and turning it into simple sugars that allow the fungi to grow, that there's an energy exchange there. And is there some way that we can basically harvest that energy and use it for another purpose. Water purification, and NASA's interested in this because if we go to the moon or the Mars, and if you've seen in the news, India recently put a lander in the deeply shadowed areas of the South Pole because they think that there's water ice there. Obviously, if we're going to put humans back on the moon and Mars, water is a critical element, and it has to be pure, potable water. So melanin may be a way to make sure that as you process that water, you get everything that's bad out of it, and it becomes potable water. It's possible maybe that we could use this for battery anodes and cathodes because of its affinity for free radicals. Spacesuits. We can weave radiation is a huge issue on both the moon and Mars. If you think back about the Apollo era days, the astronauts went to the moon, landed on the moon, and they stayed for a very short period of time. And that short period of time was not dictated by how, the amount of resources that they could put on the moon. It was dictated by how much radiation these astronauts could be exposed to without sacrificing their health. And so that's what was the limiting factor. So if you put melanin in a spacesuit, into the fabric of the spacesuit, you may be able to provide some inherent radiation protection. Chris Maurer, he's come up with some terrific ideas about radiation shielding habitats. I've talked just very briefly about sensors and electronics for extreme environments that are also biologically compatible. Melanin is already in our bodies, and so, if we are able to develop a sensor, maybe we can implant that sensor that, our body is completely fine with and adapts to, so that we can monitor astronauts long term without them being wired up with all sorts of sensors on the outside of their bodies. And that would be important, especially for long duration types of activities where we intend to go back to the moon and Mars and not only just visit, but stay. Thermal protection, heat shields, heat sinks. Again, it has high thermal conductivity. Protecting people. Okay, I gotta wrap things up. I'm getting the sign. It's hydroscopic, antidescant, mechanical reinforcements. Again, I have batteries and anodes and cathodes up there. And uniform broadband absorption. And so, I'm sorry, that was my last slide. I'll just stay there. Thank you. I know that I had to go kind of quickly. It is a fascinating material, and I'm looking forward to talking with the rest of the folks and hearing the other presentations. Thank you for your time.